But whenever there is mention of quantum, quantum physics, quantum mechanics, it's also a good idea to remember the distinction from Newtonian physics. Newtonian physics really is the physics of the material plane, the physics of the large constructs, and quantum physics is more of a physics of the subatomic world. The subatomic particles behave differently than large atoms. Quantum biology, as a result, is really the study of the smallest structures of molecular biology, their quantum characteristics and mechanics. This is the reaches all the way to the nano world. Since this is a brief introduction on quantum biology, I'm just going to quickly make a distinction to classical biology as well. So classical biology is what most of us have studied throughout our education. It's the study of living organisms based on the principles of Newtonian physics and chemistry. So really, it's just a description of matter at large scales. Quantum biology, to reiterate, is the study of how quantum mechanics and physics of the very small influences biological processes that we experience. Because subatomic particles can be in two places at once, and they can behave like waveforms, quantum biology essentially looks at the quantum phenomenon such as quantum tunneling, quantum coherence, and quantum entanglement being involved in critical biological systems. The quantum phenomenon also function very differently in terms of time and space at the subatomic level and can be perceived or observed differently at larger scale. So while classical biology is based in Newtonian physics, quantum biology is based on quantum physics. Classical biology, describes large complex biological processes, looks at cells, organisms, and ecosystems at a macro scale, takes into account only the form or the physical nature of the particles, and deals with the observed photons or electrons. Whereas quantum biology is really describing how the very small influences biological processes that we experience, looks at quantum tunneling, quantum coherence, and quantum entanglement, like I mentioned, takes into consideration both the particle and the waveform of any subatomic function, and deals also with the unobservable nature of photons and electrons.